Greetings, welcome to the lecture number 3 of vector analysis. Today we learn divergence. Uh, in our previous lesson, we have learned about gradient and some vector properties. Let's start. The divergence is another differential vector operator. Okay, now we have to find that how divergence is defined. Let's have a vector A that is look like ai cap plus ay j cap plus az k cap. If this is a vector, the divergence of this vector is defined as dot this. Okay, that is defined of that dot product of nabla operator or del operator, that also can be written as del of del x plus del of del y j cap plus del of del z k cap. Okay, this is the del operator, and the divergence is basically the dot product of the del operator, that also can write as I cap plus a y j cap plus a j k cap. Okay, that's also can be written as del of del x ax. This is we have learned already in the vector product chapter. I that is 1, and I dot j, mm, this is 0, as these are orthogonal coordinate I j and k. If these are orthogonal in unit vector in orthogonal coordinate, then that is, so we can write that I and I is 1. So we can write that 2 del of del y ay plus del of del z az. Okay, we have till that we have defined that divergence of vector in that manner. Next, take okay, let's take an example. We have to find the divergent of this expression. This expression r cap by r square can be written as r cap can be written as by mod of r, and there is r square, so here is r square, so this expression can be written as r cube. So we have to find the divergent of this expression. We have to find the divergent of this expression. Okay, now let's to find it, let's consider this vector r as x I cap plus y j cap plus z k cap. Okay, now to find that their divergent, what is what how the divergence is defined, this expression is defined as of del x I cap plus del of del y j cap plus del of del z k cap. Okay, their dot product is this expression defined as, so it can be written as this. So this can be written as del of del x I cap plus del of del y j cap plus del of del z k cap. Dot product of r is equal to x by r cube I cap plus y by r cube j cap plus z by r cube k cap. Okay, this also can written as, let's write it in that manner, del x, that x by r cube plus del of del y by r cube plus del of del z by r cube. Okay, this we got. Now we have to find this expression that can be write as, okay, there we have the first thing is 1 by r cube del x del by it is 1, so it plus. Now the term will be have that r cube, the this will be minus 3 of r to the power minus 4 del r del x. We have this. Okay, in the same way we will have that 1 by r cube plus y of minus 3 r to the power minus 4 del r del y. Okay, similarly we will have that r cube plus z into minus 3 r to the power 4 del r del z. Now these terms can be written as 1 by 3 r to the power 3 plus, look, these terms we can be cancel, get out these terms is common in every factor, so we can write that these terms will be minus, just take the minus term of this. Just take the minus term of this, you know what, 3 will be common by r to the power 4. Okay, now this value will be x of dr dx plus y of dr dy plus z of dr dz. Get. And another thing we already have that this r square is x square plus y square plus z square. So if we have that, then dr dx with derivative both side with respect to x will be get 2x, and it is 2r 2x, that is r square. So and the rest of the term will be 0 as we are doing it with respect to x. So dr dx is basically cut out down, and it is x by r. The same way dr dy will be y by r, and del r del z will be z by r. Okay, so this term can be written as this term can be let's take it so this term can be written as, this term can be written as 1 by r cube minus 3 by r to the power 4, and this is x by r plus y by r plus z by r. Okay, now 1 by r cube minus 3 by r to the power 4, and we'll have here what we'll get, x square by r plus y square by r plus z square by r. What do we have that? So that can be written as r cube minus 3 by r to the power 4, x square plus y square plus z square is equal to r. Okay, r square by this is all that r, so it will be r. And now more thing, that is not 1, that is 3, because there is 1 plus 1 plus 1, we have made a mistake there, so that is 3. So this term will be 0, so divergence of that term will be 0.